So the first thing that I want to say is, no matter what kind of a line we're finding, I always need two pieces of information. I always need a slope and a point. And with that, we have three choices for the form that that equation of a line takes. But looking at this problem, let's see if we can find the point and the slope that we're talking about. So I've asked us to find the equation of the line that passes through 2, 5. Great, so we've got our point. And is parallel to this line. So the word parallel means that it's going to have the same slope. So when I read this line, this is in our comfortable y equals mx plus b kind of form, which means that that coefficient on x is telling me that the slope is equal to 3. Putting those two things together, I would say that in probably every course leading up to calculus, y equals mx plus b is probably the equation of a line we're the most familiar working with. But in calculus, the equation of the line that we're going to start with the most often is actually the point slope form. Y minus y1 is equal to m times x minus x1. You can always use either one of these equations. This one for me is generally a little bit faster because this one relies on specifically knowing the y-intercept or finding the y-intercept. And this version for the equation of a line, it doesn't matter what point we use, as long as it's a point on the line. So here, if I use this version of the equation, I would have y minus 5 is equal to 3 times x minus 2. And this is a perfectly valid equation for a line. But if you are more comfortable having that written as y equals mx plus b, it's not too bad to distribute out the right-hand side and simplify it down. So I'm looking at y minus 5 is equal to 3x minus 6. And then if I add 5 to both sides, y is equal to 3x minus 1, which looks like it matches the answers for the couple of people that put risk boxes in there. And the way that we're going to find the slope of that tangent line, remember, we're going to start at A, and then we're going to move over a little bit. So, and then we're going to squeeze that distance back down in. So if I had a generic picture, and that's my f of x, and I wanted to find the slope of the tangent line at this point, a comma f of a, then we would move off of that point just a little bit over here to a plus h, which means that this y value would be f of a plus h, and then we would let that h squeeze down to 0. So we would get that this slope is the limit as h approaches 0 of, and then we're doing change in y over change in x, so I'd have f of a plus h minus f of a all over h. And we talked about notation, that's the slope, but notationally, we can also write that as f prime of a. There's an alternate way that we can write this, and it is in our textbook. For the folks in Kuba's class, he tends to do it this way, or with a delta x. His handwriting is much better than mine. I use h because of my poor handwriting. The other way that we can think about this is if I had that same picture and I labeled this as a, so that I had a f of a, then I can move over here to some new point t, and that would make the y value f of t, and then I can make t approach a. So rather than writing the limit in terms of the distance between the two pieces, we would actually let t approach a. So the alternate definition here would be that f prime of a is equal to the limit as t approaches a. And here we're going to be careful. So we're looking at change in y over change in x. Well, my change of y is going to be f of t minus f of a. But my change in x on the bottom, we're going from t to a. So we still need a t minus a in the denominator. And I will say that there are some times where this is kind of easier algebra-wise, but most of the time this version is easier algebra-wise. So that's kind of where we're coming from definition-wise, and I'd like to apply that to a couple of problems. 2. And just anticipating a question someone might ask me, where did I get the 2? That 2 came from plugging in 1 to the function. So 1 squared is 1, 3 times 1 is 3, 3 minus 1 gives me the 2. So if I need to find the slope of the tangent line at the point 1, 2, then I know that I'm going to call that slope f prime of 1. And I'm going to get that value by looking at, I'm going to need a little, maybe I can squeeze it in here. The limit as h approaches 0. And I'm going to have f of 1 plus h minus f of 1 all over h. Well, that f of 1 plus h, I'm just going to come off to the side to do that part of it. If our function here is 3x squared minus 1, don't write this next bit. I'll tell you where to pick back up in your notes. If I wanted to know what f of 2 was, that means I plug in the 2 where I've got the x, I'd have 3 times 2 squared minus 1. If I wanted to know what f of negative 17 was, I'd look where my x is, go 3 times negative 17 squared minus a 1. If I wanted to know what f of k was, everywhere I've got an x, I'm going to plug in a k, and I'd have 3 times k squared minus 1. But we don't actually want any of those things. We want f of 1 plus h. And f of 1 plus h says figure out where my x is and do 3 times what I'm replacing x with squared minus 1. That's the part you should write in your notes. This was just a review of how our function notation works. So I'm coming back over here and I'm going to have a limit as h approaches 0, and I'm replacing that f of 1 plus h with that piece we just found. 3 times 1 plus h whole thing squared minus 1. And f of 1 is 2. So I'm subtracting 2. That whole thing is over h. Now I've got this limit problem. Well, what do we try with a limit problem? We plug the value in. If I plug in 0 for h, then I've got 1 squared times 3. So now I'm at 3 minus 1. Now I'm down to 2. 2 minus 2 is 0. And I've got 0 on the bottom. And 0 over 0 is always whispering to us, go do some algebra. So the algebra that I need to do, well, I have some kind of polynomial thing. I've got a thing in parentheses here. So let's multiply it out and hope that nice things happen. If I FOIL that out, I'm going to end up with 3. I'll have 1 plus 2h plus h squared. And I'm going to go ahead and combine these two to make them negative 3. And that whole thing is over h. We'll see if I've got enough space here. I think I do. On my next line, I'm going to distribute this 3 to each piece and end up with 3 plus 6h plus 3h squared minus 3 all over h. I can see that my 3 and my minus 3 are going to cancel. And now I have the option. We can either think about factoring an h from the top or writing this as 2 separate fractions. Right? So if I write it as 2 separate fractions, then I'd have 6h over h, which would become 6. And I would have 3h squared over h, which means one of those h's would cancel out. And I've got just enough space to squeeze this into the corner. So I'd have the limit as h approaches 0, and this would become 6 plus 3h. So our final answer in terms of the slope, now that I don't have a denominator, when we plug in 0 for h, nothing bad happens. When we plug in 0 for h, we get an answer of 6. So the slope of the line tangent to f of x equals 3x squared minus 1 at the point 1, 2 is 6. From there, I could ask you to write the equation for the line. So let's say I asked us separately now to write the equation of the line. So for any equation of a line, I always need 2 things. I need a slope and a point. So in this case, I've got a point and I've got a slope. So I'm going to use y minus y1 is equal to m, which was 6, times x minus x1. And then if we want that to look like y equals mx plus b, we can absolutely distribute things out. So I'd have y minus 2 is equal to 6x minus 6. And if I add 2 to both sides, I've got y is equal to 6x minus 4. If I don't give us a particular point, and if I don't give us a particular point with a value of a, then generically, we're going to leave that x in there. And we call this the derivative function. So this guy is our derivative function. And we can think about that as a rule that's going to tell us for any point x on the graph, once we have our derivative function, we would then be able to determine the slope. So let's do this for a couple of functions, and then we will have some fun working towards shortcuts of derivatives. I can pretty much guarantee, well, no, I can guarantee for Kuba's second midterm, you will have at least one problem where you have to find the derivative using the limit definition formula. So I guarantee you that is one of the problems on Kuba's second midterm. So let's pick a function. Let's find, I'm going to erase this because I might need all the space in the world. I'm not sure. But let's find f prime of x for f of x is equal to the square root of x minus 3. First of all, at this point, The only thing we've got to go on is that limit definition of the derivative. So I know that my f prime of x needs to be the limit as h approaches 0 of f of x plus h minus f of x all over h. And for those of you that may have had a really awesome pre-calc teacher, you have probably messed around with this before. Sometimes we refer to this as the difference quotient. Quotient because we're dividing, and difference because I'm subtracting two things on the top. Sometimes that's referred to as the difference quotient. And if you hated your pre-calc teacher for making you do those, there was a reason. They were making you do it so that you'd be ready for it in calculus. Okay. In the context of this equation, if f of x is equal to x minus 3, then I know that f of x plus h says wherever there's an x in this equation, plug in x plus h instead. Well, that means if that's f of x, then f of x plus h is the square root of x plus h minus 3, because I'm replacing the x with x plus h. It doesn't need to be in parentheses. I just put it in parentheses. So I am looking for a limit as h approaches 0. And I'm going to replace the f of x plus h. This is our formula, and I'm going to replace that piece to now have x plus h minus 3 minus f of x. So I'm not going to do anything to the f of x. I'm just going to copy it back down here as an x minus 3. And the whole thing is over h. First thing we try with the limit problem is to plug in the 0 for h. Fun fact, if you set this up correctly, it will always give you 0 over 0. So we're just going to move on with the algebra. Since I've got square roots, I know that the algebra I'm going to need to do is to multiply by the conjugate. So I'm going to have square root of stuff plus square root of stuff over square root of stuff plus square root of stuff. X plus h minus 3, x minus 3, x plus h minus 3, x minus 3. And this has been the theme through all of our limits. Because I want that h to cancel out, I do not want to distribute it over here. I want to leave this as h times the square root of x plus h minus 3 plus the square root of x minus 3. In the numerator, the whole reason we multiplied by the conjugate was so that the middle terms would cancel. So I've got square root of x plus h minus 3 times square root of x plus h minus 3. So I'll have x plus h minus 3. And then I've got negative square root of x minus 3 times positive square root of x minus 3. And I'm going to get negative x minus 3. In general, always, when we're doing these problems, if we've done the algebra correctly, when we simplify the top, we should be able to factor an h out to cancel with that h in the denominator. So this is one place where you might be able to catch a mistake. So here, I put that x minus 3 in parentheses. I'm going to do it wrong, so stop taking notes. If I had forgotten to put the parentheses there, and I said, oh, well, I'm doing, right, it's going to be minus x minus 3, and then I go to simplify the top, I've got the limit as h approaches 0. My x's would cancel out, so I'd have h minus 3 and then minus another 3. And I'd look at that and say, wait, the whole reason we were doing this and the whole reason we did all of that algebra was to try to make that h cancel out in the denominator. I must have made a mistake because these 3's should have canceled out. And if I come back in and put those parentheses in place, now when I distribute out that minus sign, they will cancel out. And then I'll have h over h, which is going to leave me with a 1 over And I'm ready to plug in the 0 for h. So if I plug in the 0 for h here, x plus 0 minus 3, and then another square root of x minus 3. So altogether, I've got 2 of those square roots of x minus 3. And this is our, we read that as the derivative, or f prime of x. We've got a few people that have offered up 1 minus 4x. So let's hope that when we're done, we get down to 1 minus 4x. That's what we're aiming for. But like I said, we got to practice this because I guarantee next exam for Cuba for sure has one of these on it. And I have to believe next quiz for Ben will too. So looking at the limit as h approaches 0, I need to figure out that f of x plus h piece. So looking at our function, I know that if I replace all of these x's with x plus h, this is going to be x plus h minus 2 times x plus h squared. I barely squeezed it in, but it's okay. Because really what's important is I'm going to put it down here. I'm going to take that whole thing and plug it in for f of x plus h. So x plus h minus 2 times x plus h squared. And then I'm subtracting f of x. I'm going to be careful to put that f of x in parentheses for right now. X minus 2x squared. It is possible that in a previous life, you learned to deal with the top by factoring that as the difference of perfect squares. If you are used to doing it that way, you just keep right on doing it that way. My brain looks at that mess on top and says, I guess I have to multiply it out. So that's the way that I'm going to go, because I think that's, when we're first starting on these problems, I think that's the most natural thing that your brain might want to do in terms of algebra to the top. So I've got x plus h. It doesn't need to be in parentheses because we're just adding 2 things. I'm going to have negative 2 times, and this one I'm going to keep in parentheses for a minute, just because I need to write out that step. So that x plus h squared, I'm going to get x squared plus 2xh plus h squared. And then I'll go ahead and distribute that minus sign through. So I've got minus x and plus 2x squared. And then the whole thing's over h. I'm hoping that when we distribute things out, anything that does not have an h in it is going to cancel out for us. Well, already I've got one thing that's canceling out, because this minus x and this x out in front, those can cancel. And I'm going to distribute that minus 2 out and hope that some more stuff cancels. So I've got h minus 2x squared minus 4xh minus 2h squared plus 2x squared. I think I got all the pieces, all over h. See if we can find anything else that cancels. Looks like the negative 2x squared is going to cancel with my positive 2x squared over here. And then once again, we have a choice. I've got a single piece in the denominator, so we can either factor in h out of everything in the top, or we can write this as 3 separate fractions. Since I wrote it as 3 fractions before, I'll go ahead and factor this time. But either one should work for us. So I've got a limit as h approaches 0. And in the numerator, when I pull an h out, from here I'll get 1. Here I'm going to have minus 4x. Over here I'll have minus 2h. And that whole thing is over h. Which means that my h over h is going to cancel out. And then I'm ready to plug in our limit that h is equal to 0. And I'd get 1 minus 4x minus 2 times 0. Bam, we're right. Let's use our limit definition of the derivative, see what happens. Well, if I need to take this limit, I am looking at the limit as h approaches 0. While f of x plus h is where I've got an x, I'm plugging in x plus h. So I'm going to have 1 over x plus h squared plus 1 minus 1 over x squared plus 1 whole thing over h. Well, that is terrible. But we're going to fight through it together. Because I'm a little short on space in this whiteboard, I'm going to do a couple of things. I am going to erase that division by h, and I am instead going to write that as this entire thing times 1 over h. Now the other thing I'm going to do is, again, because I'm a little short on space, I'm subtracting fractions, so I know I need a common denominator. I'm going to go ahead and just get my common denominator in right on this line. But I need a little more space to do that. Sorry. So I've got that minus 1 over x squared plus 1. And then we're going to be times 1 over h. Because dividing by h is the same thing as multiplying by 1 over h. Now I'm going to squeeze in my common denominator. So here, I need to multiply by x squared plus 1 over x squared plus 1. And over here, I'm going to have to multiply by this entire denominator. So x plus h squared plus 1 over x plus h squared plus 1. That looks like a minus 1, at least from where I'm standing. So I'm going to try to make my handwriting a little bit better. Now for the algebra. The reason to get a common denominator is so that we can write that entire thing as one big old fraction. Similarly to those problems where I said don't distribute out the h, there's no point in trying to simplify any of this. The only thing we have to deal with in this limit is to make sure that h that was in the denominator cancels out. So I'm just going to leave that denominator of this big old fraction ugly, or at least messy. Maybe it's not ugly, but it's going to be messy. So I've got x plus h squared plus 1 times x squared plus 1. And then we've got our times 1 over h out there. I didn't really need those parentheses. And now in the numerator, when I'm combining those fractions, I've got 1 times x squared plus 1. So I'll have x squared plus 1. And here I've got negative 1 times that x squared plus h plus 1. So I'm going to take that negative and distribute it. So I'll have minus x plus h squared and then minus 1. We're getting close. In that numerator, I know that I can take the 1 and the 1 and cross those out. And now if I expand out the x squared plus h squared, I've got x squared. And I'm going to go ahead and talk through this, but I'm going to distribute that minus sign out. So I'd have x squared, which will be minus x squared. I'd have a plus 2xh, but I'll distribute the minus sign and get a minus 2xh. I'd have an h squared, but I'll distribute the minus sign and have a minus h squared. And in the denominator, I still have that whole mess. X plus h squared plus 1 times x squared plus 1, and then whole thing times 1 over h. Well, in my numerator, now that x squared minus x squared, that's going to go away. And here, since both of these remaining terms have an h, I should be able to factor that h out. So I've got the limit as h approaches 0. In the numerator, I'm going to pull out that h and have negative 2x minus h. My denominator isn't going to change. So x plus h squared plus 1 times x squared plus 1, whole thing times 1 over h. We're getting close. So that h is going to cancel out. And I'm ready to take every h in this limit and replace it with a 0. So I'm going to replace this h with a 0 and this h with a 0. And I don't know where else to put it, so I'm going to put it up here. And get that f prime of x. So in the numerator, that h goes to 0, and I've got negative 2x. And in the denominator, when that h goes to 0, I've got x squared plus 1 times another x squared plus 1. There are some ways that there are some different ways that we can write this. And for sure, this is not what the answer would look like in the back of the book, because in the back of the book, they're going to say, oh, I got 2 of the same thing in the bottom. I can write that as the thing squared. So this is the same as negative 2x over x squared plus 1 squared.